For the last few years, the entire AI revolution has been running on this one super simple and incredibly powerful idea. Bigger is better, right? More data, bigger models, more compute. It just seemed like the obvious path to superintelligence. But what if that entire assumption, the one we've bet billions on, is built on a huge misunderstanding of what intelligence really is? Okay, let's get into it.
So, this is the big question we're going to tackle. Is a bigger AI really a smarter AI? We're going to unpack why having a giant memory is not the same thing as having a sharp mind, and why that difference could change, well, everything for the future of AGI. For a long time now, the whole industry has been completely dominated by something called the scaling paradigm. This is the core belief that if you just keep making models bigger and you keep feeding them more and more data, eventually real general intelligence will just pop into existence. And to be fair, this formula worked. Like, it worked amazingly well. It absolutely demolished almost every benchmark you could throw at it, from writing code to passing the bar exam. This is the engine that built the powerful large language models we're all using today. But, and this is a big but, this incredible success story was also creating a massive blind spot. And this is where AI researcher François Chollet comes into the picture. He argues that we, as an entire field, are making a huge mistake, a category error, really. He says we've been confusing two totally different concepts, an AI's learned skill and its actual, real-deal fluid intelligence. Okay, on the left, you've got skill. The easiest way to think about this is like a giant, preloaded library of answers. It's all about applying solutions you already know to problems you've seen before. Our current AIs, they are absolute masters of this. Then on the right, you've got intelligence. This isn't about knowing the answer. It's about being able to figure out the answer to a problem you have never, ever seen before. So here's the kicker. Scaling up a model's memory definitely increases its skill, but it might not be increasing its actual intelligence one tiny bit. Let me give you a perfect example. An LLM can solve a Caesar cipher, where letters are shifted in the alphabet. It can do it easily if the shift is something common, like 3 or 5, because it's seen thousands of examples of that online. It's memorized the pattern. But if you ask it to solve a cipher with a weird, random shift, like, say, 11, it often just falls apart. It hasn't learned the general way to solve ciphers. It's just grabbing a specific solution it already has saved. That's pure skill, not real-time reasoning. And this quote from the brilliant developmental psychologist John Piaget just hits the nail on the head. Intelligence isn't about having a huge database for all the situations you do know how to handle. Real intelligence is what kicks in when you're faced with something new, with uncertainty. It's your toolkit for the unknown. Now, to make this distinction even more clear, Chollet came up with this fantastic analogy that I think just cuts right to the heart of the issue. It's the difference between having a map and being a mapmaker. This analogy is just brilliant. Think about today's AIs as an incredibly detailed road network, like Google Maps on steroids. They can get you from point A to point B with superhuman speed as long as a road already exists in their training data. But what happens when you need to get to a place where there are no roads? You're completely stuck. Now, a truly intelligent system, that's like a road building company. It can look at brand new, uncharted land and say, no problem, I'll just build a new road right here. It's not just using the map, it has the ability to draw the map. So this leads to the million-dollar question, doesn't it? If all of our current tests are basically just checking how big and detailed the AI's road network is, how do you even design a test that can't be cheated by just having a bigger memory? How can you actually measure the ability to build new roads? Well, this is exactly why Chollet went and created the Abstraction and Reasoning Corpus, or ARC for short. You can basically think of it as an uncheatable IQ test for machines, one designed from the ground up to ignore memorization and actually measure that fluid, road-building kind of intelligence. Okay, so let's break down what makes this ARC test so different. There are 3 key things. First, every single puzzle is completely novel. It's unique. You can't just go find the answer on the internet. Second, it doesn't require any specialized, high-level knowledge. All you need are the basic concepts a 4- or 5-year-old gets, things like objects, counting, basic symmetry. And third, because of that, the AI is totally forced to reason its way to a solution from scratch, right there on the spot, no fetching old answers. For years, the results from the ARC test painted a really stark and frankly pretty shocking picture. It revealed a truth that basically threw a wrench in the entire bigger is better story that was driving billions of dollars of investment. And to put this into perspective, just think about this. Between 2019, when ARC first came out, and 2024,
The size of the biggest AI models grew by about 50,000 times. With that kind of absolutely insane exponential growth, you would expect a revolutionary jump in performance, right?
Well, here's the punchline. Despite that 50,000x increase in scale, the performance of these models on the ARC test barely moved. It went from basically 0 to only around 10% solved. Meanwhile, the average person, we score over 85%. This wasn't just a small gap. It was a chasm. It was the proof that simply making a model's memory bigger was not making it more intelligent in a general, flexible way.
But here's where the story takes a fascinating turn. This massive failure wasn't a dead end. In fact, it was the exact opposite. It was like a giant flashing neon sign pointing the whole field toward a completely new and way more promising path to AGI. The breakthrough finally came when researchers stopped just trying to throw bigger, static models at the problem. Instead, they started building systems that could actually adapt on the fly, systems that could learn and change during the test itself. This whole approach is called Test Time Adaptation, or TTA. You can think of it as the machine equivalent of us thinking through a brand new problem from scratch. And this all points to a new architecture for intelligence, one that, funny enough, mirrors how our own brains seem to work. We have what's called System 1 thinking. That's our fast, intuitive, gut-feeling kind of thought. That's what deep learning is amazing at. And then we have System 2. That's our slow, deliberate, step-by-step logical reasoning. The problem is, if you try to use only that slow, logical reasoning on its own, you run into this combinatorial explosion of possibilities. It's just way too slow to be practical. So the path forward looks like it's all about hybrid systems. You use the powerful, fast intuition of a deep learning model, your System 1, to guide the slow, careful logic of a programmed search engine, your System 2. The intuition part basically tells the reasoning part, hey, don't waste your time looking over there, the interesting stuff is probably over here. This makes the whole problem solvable. The ultimate goal is to create what Chollet calls a programmer-like meta-learner, an AI that can literally write new code for itself on the fly to solve any new task it runs into. So you see, this whole distinction between skill and intelligence, it's not just some academic debate for researchers. It forces us to make a very real, very fundamental choice about what we are actually trying to build with all this technology. The question is this: should we keep building AIs for automation, or should we start building them for invention? Are we just trying to get better and better at automating the tasks we already know how to do? Or are we trying to build a true partner in invention, a system that can help us solve the huge problems we don't have answers for yet? That choice, the choice between building a bigger, more detailed map or building a true map maker, is going to define the entire next era of AI.